Hello everyone, in this video we're going to explore absolute value functions. Recall absolute value of s equals s if s greater than or equal to 0, negative s if s less than 0. Example number 1. Determine whether the statement is true or false. Justify your answer. Question 1. The graphs of f of s equals absolute value of s minus 2 and g of s equals absolute value of negative s minus 2 are identical. This is true. Why? Because if you take absolute value of negative s, it's actually absolute value of s, right? Minus 2 and this guy the same. Question 2. The graph of f of s equals negative absolute value of s plus 1 plus 4 is the graph of y equals absolute value of s, translated 1 unit left, translated 4 units up, and reflect across the x-axis. This is false. If you want to review the topic of transformation of functions, please check out the link in the description below. Alright, remember the order of transformation is going to be B, H, A, K. Alright, the general form is going to be first you need to perform B, right? There's no B right here. Next one, you need to perform H, right? H right here. So, you see the plus sign right here, which means it's moved to the left. Yes, it's correct. The next one, A, which means you need to do dilation or reflection first, right? So, you have the negative side right here. You need to reflect over the x-axis first, right? So, this step before this step. Right? So the order is incorrect. Question 3. If the graph of y equals f of s passes through the points 0, 1, 1, 2, and 2, 3, then the graph of y equals f of s plus 2 minus 1 passes through this point. This is true. Why? Look at this one, s minus h, which means you move to the left 2 units, and you move down 1 unit right here, right? So you have 0, 1 right here. You move to the left, which means you subtract 2. You move down 1, which means you subtract 1, right? So it could be negative 2, 0 is right here. Similarly, you have 1, 2, subtract 2, subtract 1. It's going to be negative 1 and 1. It's going to be right here. And the third one, 2, 3, subtract 2, subtract 1. So it could be 0, 2. It's right here. Now question 4. The function f of s equals absolute value of 2s can also be written as f of s equals absolute value of 2 times absolute value of s. Yes, it's true, right? Because if you take absolute value of 2, it's still 2. This guy is still 2, right? So they're both the same. Now example number 2. In exercise 5 and 6, the graph of y equals f of s is shown. Question A. Determine the domain and range of the function y equals f of s. Alright, so domain is going to be from here to here, right? And range is going to be from here to here, right? So, domain is going to be negative 4, 2, 5, right? And range is going to be negative 3, 2, 4. For this one right here, the domain should be negative 8 to 8. And the range should be negative 7 to 5. Question B. Describe the sequence of transformation from y equals f of s to the given function. Now remember the order of transformation is going to be B, H, A, K. And the general formula is going to be A times F times B times S minus H plus K. Now look at this function right here. B equals 1, right? So we skip B, right? Next one, H. H equals negative 3, right? So first we're gonna move left 3 units. Now next one, A equals 3 right here, right? So we're gonna do vertical dilation by factor of 3, right? Now you have the negative side right here, so you need to do reflection, right? Reflect about the x-axis. And the last one, k equals negative 3. You're going to move down 3 units. Now to be more specific, this guy right here you can write as vertical stretch by factor of 3. And this step right here you can swap, right? Now question 6. You're going to do exactly same thing, right? Now question C. Use the graph y equals fs to sketch the graph of the given function. Now to graph this one, we need to follow the formula. For the x-coordinate, you only move left 3 units, right? So you have s, y turns out to be the new one, s minus 3, right? For the y-coordinate, you're gonna multiply by negative 3 and you subtract 3, right? So you have negative 3y subtract 3. For this one, you're gonna move right 6 units, right? So s plus 6. For the y coordinate, you're gonna multiply by negative 1/2 and add 5, right? Now you just list all the pairs right here. Alright, so negative 4, negative 3 becomes negative 4 subtract 3, negative 7. Negative 3 times negative 3 equal to 9. 9 subtract 3 equal to 6. Alright, so the new coordinate negative 7, 6. It's going to be right here. Negative 5, 3, right here. Negative 4, negative 9, right here. Negative 2, negative 3, should be right here. 0, negative 15, and 2, negative 15, should be down here. So if you connect this one, it should be something like this. Now, number 6, you do exactly the same thing, right? So I'll leave this one for you to practice. Question D. Determine the domain and range of the graph of the given function. The domain should be from the left right here. This is negative 7 right here, right? All the way to the right here. It should be 2, right? And the range, the bottom right here is negative 15, and the top right here should be 6, right? Example number 3. Graph the function fs equals absolute value of s minus 3 minus 1. Then find the domain and range, maximum, minimum, x-intercept, and y-intercept. Alright, so remember the absolute value function has the formula s minus h plus k, right? Where h and k is the vertex. In this situation, it's gonna be 3, negative 1, right? So I'm gonna locate 3, negative 1. It's gonna be right here. We know that the axis of symmetry is s equals h. In this situation, s equals 3 is the axis of symmetry, right? So I'm gonna sketch the axis of symmetry, and I'm gonna take advantage of the axis of symmetry to sketch the absolute value function faster, right? Now I'm going to take s equals 0 to see what happens, right? Substitute 0 for s over here. So I have 0 minus 3 could be negative 3. Absolute value of negative 3 is 3. 3 subtract 1 is going to be 2. So it could be s equals 0, y equals 2 right here. By symmetry, you have the reflection points right here, right? Now I'm going to take s equals 1 to see what happens. Substitute over here, I have absolute value of 1 minus 3 minus 1. It's going to be 2 minus 1. It could be 1. So s equals 1, y equals 1. It could be right here. So by symmetry, it should be right here, right? right? So I'm going to connect these points. Alright, so here's the graph of the function f of x. Now, the domain from left to right is going to be negative infinity to positive infinity, right? The range is going to be right at the vertex right here, right? Minimum negative 1 to positive infinity, right? This guy keeps going up. Now, the maximum, there is no maximum, right? The minimum, y equals negative 1, right? X-intercept, y-intercept is going to be right here. Now let's move on to example number 4. Graph the function below, then find the domain, range, maximum, minimum, x-intercept, y-intercept. Remember, the domain is going to be negative 6 to 2. Now, if you substitute x value into this function, then you're going to get the following values. Now, you just plot these order pairs on the x and y coordinate right here. You're going to get the following graph. Now, we need to find the domain, range, maximum, minimum, x-intercept, and y-intercept. Alright, domain is going to be from negative 6 to 2, right? Range should be from negative 9 to negative 3, right? The maximum is negative 3, right? Right here. The minimum is right here, negative 9, right? The x-intercept, none, right? The y-intercept is right here. It's going to be negative 5. And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand